All right, so now we're getting to another subject. This is kind of the first time we really see a formula, but finding a measure of relative standing, or we're going to talk about z-scores. So the z-score of a value is the distance it is from the mean measured in standard deviations. The symbol for the z-score for the number x would be z with a little x down here. Now the formula for z-score, there's going to actually, I'm going to talk about it. There's two depending on the situation, and we'll talk about what that means. First one is x minus x bar divided by s. You also might see x minus mu divided by lowercase sigma. What's the difference between these? We've talked about this in this video. What are the different, or in this series of videos, what's the difference between x bar and s and mu and sigma? Well, this would be the formula for a sample, and this would be the formula for a population, right? Remember that mu and sigma are the mean and standard deviation of a population, and x bar and s are the mean and standard deviation of a symbol, or of a sample. All right, so it says for the data above, find x bar and s, because you can see that we're going to need, this is sample data, we're going to need these values to be able to find the z-score. So I'm going to go to my Excel worksheet, and thankfully I already have those values typed in here from the last video, so I can see my mean is 55.5 and my sample standard deviation is 27.33. So we're going to fill that in there. So the mean is 55.5 and the sample standard deviation is 27.33. All right, so now let's find the z-score for, you see it tells us down here, the z-score we're being asked to find is for the number 50. Remember our formula. We take our x value, subtract it from the mean, and divide it by the standard deviation. So my x value here this time is that first number, which is 50. Oops. It does not want me to write this 5. 50, we're going to subtract that by 55.5, and then we're going to divide that by the standard deviation of 27.33. So we're going to go 50 minus 55.55. Make sure you hit enter here. Divided by 27.33. So I can see that my standard deviation here is negative, we'll round this 2 decimal places, negative 0.20. Let's do the same thing for the number 77. Again, we're going to take our x value, which in this case is 77. So 77 minus 55.5 divided by 27.33. All right. So 77 minus 55.5, make sure you hit enter, divided by 27.33. And that gives us 7.9. So for this next one, it is positive 0.79. What do you notice about these? Do you see the number 50, is that above or below the mean? You see when it's above the mean, we get a negative z-score. I'm sorry, when it's below the mean, we get a negative z-score. The value 77, you see that's above the mean, right? When it's above the mean, we get a positive z-score. And here's what I'm going to do real quick, just to illustrate this a little bit further. Let's take this data set. We know our mean of 55.5. Let's put that in there. And let's count up by standard deviations. And here's what I mean by that. Take 55.5 and let's add a standard deviation of 27.33. 55.5 plus 27.33 is 82.83. Let's do it again. Let's add another standard deviation up. So plus another 27.33. That gets me at 110.16. All right, let's go down. So 55.5 minus 27.33 gets me to 28.17. And let's go down one more time. So subtract 27.33, and that gets us to 0.84. So let's take a look at this first number, 50. Where would 50 be? I'm going to use a different color for this. 50 would be, I don't know, maybe somewhere like right here, right? Think about that. Is that below the mean? It's just below the mean, right? It is negative. It is 0.2 standard deviations below the mean. A number like 77 may be somewhere, it's probably somewhere about right here. Look, that one's above the mean. That is 0.79 standard deviations above the mean. And I just want to do one more thing, which is illustrate. We're going to do one more z-score. I'm going to do a z-score for 110.16. Let's count. How many standard deviations am I above the mean? Well, look, we can count them. 1, 2. So you can see that 110.16 is 2 standard deviations above the mean. What do you think we're going to get for the z-score? We better get a number like 2. So we're going to do one more z-score, which is a z-score for 110.16. How I do that is, again, use this z-score formula up here. It's going to be the x value, which is 110.16. We're going to minus 55.5, and then we're going to divide that by the standard deviation of 27.33. So we're hoping to get a positive 2 here. So 110.16 minus 55.5. Divide that by 27.33. And I think we get 2. And you can see we get 2 because, again, this counts the number of standard deviations we are from the mean. Now, we're always going to round a z-score 2 decimal places. Let me switch over to my black pen here. So, let's talk about usual or unusual values in z-scores. We did this in a previous video, but we did it in terms of standard deviations, where we took a mean and added 2 standard deviations and took a mean and subtracted 2 standard deviations. So we're going to say a data value is excuse me, considered unusually large if it's bigger than 2. And we're going to consider a data value to be unusually small if it is smaller than -2. So again, if you think about this in terms of a number line, if you're doing z-scores, if you get a z-score that is outside this range, you're going to consider it unusual.